Now problem 6 is actually quite normal. You only need to find mass fraction and stuff. So this one I think I leave it to you for fine-tuning. Problem 6, let me see. Yeah, we can discuss problem 6. All these more normal questions. No application kind of question. Okay, so we look at problem 6 here. The partial pressure of a gas mixture are given, so you are actually given the partial pressure. So, and the mole fractions, so the partial pressure here is as follows. So let's say we have a gas, let's say we have a container, for example. So make the partial pressure CO2 is 20 kilopascal. O2 is 30 kilopascal, and N2 is 50 kilopascal. Determine the mole fraction and mass fraction of each component, and you need to calculate the apparent molar mass, apparent gas constant. So again, all of everything here. Okay, so I think let me ask you better. Since the first thing that is you are asked to find the mole fraction. How do you find the mole fraction for partial pressure? Yes. What to do first? So you find the total pressure first. So partial pressure in a way is like individual pressure, each of them, but based on the total pressure. So you find the total pressure first. Okay, you can just total them out. So once you find the partial pressure, the total pressure, then the mole fractions is simply, so YCO2, let's say, is just TCO2 over T total. YO2 is simply PO2, T total, and etc. So YN2, so simply, it's just PN2 over P total. So again, partial pressure is basically just like the individual pressure of each of them. But that one, the meaning that itself doesn't really make sense because they cannot exist individually and with just a different pressure. But in a way, it's a pressure based on this. So you just need to total them up. So so the partial pressure of CO2 over the total will give you the mole fraction. So again, the volume, pressure, mole, they are all the same thing. So always remember this. So once you have obtained mole fraction, then now you can find mass fraction also. But how? Okay, so usually let's say if we convert mole to mass, we need to assume something. So in the sense that because here we everything that we have here is just fractions. We don't have the actual mole, we don't have the actual mass. So what you can do here is, let's say you just assume 1 kilomole of the mixture. Because ultimately you are just finding the ratio, so it doesn't matter. So what do we mean by assume 1 kilomole of the mixture? So let's say here the answer is just this. Okay, so the fraction here is just 0.2, 0.3, 0.5. So if you assume 1 kilomole of the mixture, meaning you are assuming 0.0 kilomole carbon dioxide, 0.3 kilomole oxygen, 0.5 kilomole of nitrogen. Alright, so why do we do this? Because by assuming their mole, then you can find their respective mass. Okay, so you use, so this mole will be what you assume, so you are assuming 0.2 kilomole, 0.3 kilomole, 0.5 kilomole, multiplied by their respective molar mass. So from here, you can get their individual mass, and then same thing, repeat. So mass fraction of CO2 is just mass of CO2 over mass total. Then mass fraction of O2, we just add mass O2 over mass total. And mass fraction of N2, same thing, add N2. So once you have gotten this, then the rest are actually very straightforward. Apparent molar mass, Nm, is just mass of the mixture over the mole of the mixture, right? So in this case, mass of the mixture is actually just 1 kilomole. Because you are looking for, because you found this mass total based on 1 kilomole of mixture. So actually the mass total that you find here is actually the molar mass.
Huh? It's more complicated. I know, right?
So apparent mass constant is just Ru over Mn that you found earlier. Constant volume specific heat is just each of the MF multiplied by their respective CV that you can get from the table.
So are you? So for K, we know that K is Cp over Cv. So you can actually just either find Cp or you know that Cp is Cv plus R, then over Cv. So you can get all these values just by using this equation. Okay, so we move on. Let's look at problem 7 here. Something more, slightly more. So for this problem, you have two rigid tanks. First one, N2, 2 kg, 25 degrees Celsius, 550 kilopascal. Second one, O2, 4 kg, 25 degrees Celsius, 150 kilopascal. So there is a valve here. So the valve connecting the two tanks is open, and the two gases are allowed to mix. So if the final mixture temperature is 25 degrees Celsius, determine the volume of each tank and the final mixture pressure. Okay, so here in this case, now rather than giving you a mixture and telling you the individual properties, we tell you that originally you have these two mixture, or I'm sorry, these two gases, and then we mix them together. Alright, so now, how would you attempt this question at first? Actually, this one very straightforward. I think the second one, the next one will be harder. Okay, just don't overthink first. Now, you look at the question, determine the volume of each tank. This one you can find, right? How? Yeah, so PV equals MRT. You can, so you do them separately. So one for the, so V equals to MRT over P. You find for N2. So this whole thing you use N2. Then VO2, you can find P. And this one also, this one for O2. You need the R value from the table, but other than that, temperature, pressure, mass, they are all given by the question. So you can find the mass, the volume of each tank, right? So here we settled with the first one. Then now we look at the second part. So second part asks for the final mixture pressure. Then what do we do here? And what can we do here? You want the pressure of the mixture. Yes, so it's the same equation actually. Basically P V equals to, so you have two equations, or R U T. You can decide which one is easier for you to use. So for volume, it's just the total volume from here. Because final mixture, meaning they mix together, so the volume should just total up. So this V is just the total of this. P is what you want to find. Mass, you can total them up also. T, we know the final temperature, which is 25. The only issue now that we have is R. So you have two ways to do this. One, you need to find the molar mass for the mixture first. But that one is a bit troublesome. Actually, it's the same thing. That one is a bit troublesome. Why? Because to find the molar mass of the mixture, you need to find you need to find, so we know R. Okay, ultimately it's the same thing. So you see, we know R is RU over molar mass. Which means this one is, which means you need to find this, which is M over N. Total. Mass is just plus. So you need to find their individual mole.
Just use the B get then plus C.
No, the mass that you get correct, but you don't have R. That's why I say you need to do this.
But the M we get is same as the volume ratio. We get the volume outside. Now that's how we do. Compare the V for MU and OU up. Then we just plus.
Yes. Yes. So V you just plus, correct?
Then for
M also you just plus.
N also.
N you can just plus, but you need to find the individual mole. Mole fraction and mole are two different things. Don't get confused by that. Mole fraction is just a fraction, but it is still not the mole. So, actually same thing like I said, because either way you need to find the total mole. So what you need to do is, so you need to find N of N2 and N of O2. So this one is just MN2 over the molar mass. This one also same thing. So once you found the individual mole, just sum the total mole either into this one or you use it to find the R, then sum into this one. It's the same thing. At the end of the day, it's the same thing. So this is the total, or maybe just write picture. So you need to find the individual mole. So either use the mole to find the Rm, then you use this equation, or you use the universal one. You just need the mole. That's all. It's the same thing. Again, I think. But these two equations actually they are the same equation.
M 是头个 M， 然后 R 是如果是在 N 读它的 R， 它的 R 就是没有这个。哦，所以要找的是 R。volume 我们没有。
所以它是怎么办？就是把上找 perspective 我们在上切。
所以 volume 怎样找？
就是等于 MRT。上面上面两个是。
找到 volume，M 有 ，R 没有 ，R 还是没有，我想找。哦 ，RM 有。RM 等于I see RM， 所以要找 volume 之前要找 RM， 对吧？找 RM， 找 RM 就是 RU over M， 那个table， table 的吗？没有啊。哦，那本书哈。哦，对。
Okay, let's move on.
是因为它是 R 头的，因为它不同。
We look at problem 8 now. Problem 8 is a similar question, but we
就
added
就是
before next
ratio
to it.
ratio 大概懂大概懂
So you have a rigid tank. Once again, a rigid tank. So the total volume here is 0.9 meter cube. It is divided into two equal compartments, so divide right in the middle by a partition. So one component contains neon at 20 degrees Celsius, 100 kilopascal. The other one, argon, 50 degrees Celsius, 200 kilopascal. So now the partition is removed and the two gases are allowed to mix. So similar to the previous question, where just now we just on bar. Now this one we remove the partition. So, but here we added one extra thing for you. So when the gas mix, we say that heat is lost to the surrounding air during this process in the amount of 15 kilojoules. So you actually have a heat loss of 15 kilojoules. So A, you need to determine the final mixture temperature, and B, you need to determine the final mixture pressure. So the hint here is to use CV at room temperature. There was not much of a hint, but to use CV at room temperature. Okay, so how will you approach this question now that we have an additional heat loss here? So this one is slightly different because you need to find the final temperature and pressure, meaning they don't tell you anything about the final state. The final state, the only thing that you know is the total volume. So compared to the previous one, now you have one less information. What can you do here? I'll give you another hint. What system is this?
close
Yeah, this is a closed system. That's my hint.
so good
You still remember how to approach closed system? What is this? Yeah, so you have Q here, so obviously you need to involve some form of energy, right? Then closed system energy equation, E minus E out equals to delta E system, and usually we write it as Q minus W equals to delta U, right? So in this case, what we have is Q out, and that's all. There's no work as well, so you are left with, so let's say if you write the full thing term, Q in minus Q out, minus work out, minus work equals to delta U. So this one cancel, 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 what you are left with is Q out equals to M, or maybe, never mind, just write delta. So delta U equals to So this is the general equation. Now, the main question here will be, how do we approach this U? Now, usually we have one substance only when we deal with closed system. In this case, you have two, right? So meaning delta U, technically you can analyze them separately. So meaning you need to look at the delta U of the neon and the argon separately, individually. And how do we deal with that? So the hint here, use CV at room temperature, which means so delta U will be equal to CV delta T, right? Or MCV delta T. So what you do is this, you do MCV T mixture minus T1 for neon plus MCV TM minus T1 for argon. Can you guys understand this equation? Basically, the change in the internal energy of the neon plus the change in the internal energy of the argon. Okay, so this M will be the M of the neon, this M will be M of the argon. CV and CV also same thing. So CV you can get from the table once again. So T1 will be 20 and 50 degrees Celsius. Tm is the final temperature of the mixture, because at the end of the day, after they mix, they will reach the same final temperature. So this Tm will be based on the final temperature. Okay, so what are we missing here? So what do we need to find here based on this equation?
Temperature. Final temperature.
No, temperature is what you need to find at the end, but then we are still missing something. If nothing is missing, you need to solve. Mass. So we don't have their individual mass for neon and argon. So you need to find these two. So once again, how? Yeah, I don't know what to do. PV equals don't need also, because you're given you're actually given temperature, pressure. So total is 0.9, but you know that it's divided into half. So 0.45, 0.45. So you just need to use PV equals to RT. So M equals to PV over RT. You can get M for neon. You can also get M for argon. So the R you can just get from the table as well.
Okay.
If you don't have, then cannot be don't have lah. But anyway, you can still get the molar mass from the molar mass. You can still get the gas constant. So once again, yeah, we come back to PV equals to MRT. So you sub this into this equation, you will get Cm. So for this question, one thing that is very important is the direction. So this Q out must be a negative value, and this Tm must be final minus initial. Because if you accidentally swap one of them, the value will not be correct.
这个 Q 是0.5，2换，不是，所以
你不能打这个每个 molecule 的 mass 对不对？所以每个人 R 都不一样。
所以我们叫测的啊，这边的，应得不？
Okay, so once you get the final temperature, then yeah, you can recycle this again to get the final pressure. So here same issue lah. You either find their individual mole and total them up, or you need to find the R for the mixture. So the last part is the same thing as the previous question.
这不是 ratio， 它是 gas constant。Are you 什么？universal gas constant。对啊。给我这本书。
Okay, so we have one last note and one more question.
就是跟你不够熟
So。we just look at problem 9 now. Okay, so a mixture consists of 15% nitrogen, 5% helium, 60% methane, and 20% ethane by mass. So these are all mass fractions. So again, you have a mixture in a rigid, well-insulated vessel at 150 kilopascal and 30 degrees Celsius. And this vessel has a paddle wheel. So the 15% into 5% He, 60% ethane, CH4, 20% ethane. And this is at 150 kilopascal, 30 degrees Celsius. So this paddle wheel has 200 kilojoule of work, so work sharp. Calculate the mixture final pressure and temperature. So you can see this is actually similar, but without the initial mixing, but it's still the same thing. We are just mixing them. Okay, now one thing for you to know. Let's say in exam, if you see like the question says methane, ethane, but you can see the question doesn't give you the formula, right? If the question doesn't give you the formula, it is usually available in the table. Just look through it. If it is there one. If you cannot find the table one, I will give you. If I don't give you anything, it is there. Don't hesitate, just look through the table. It will always be there. Right.
Can I have a question?
没有，因为明天那个打的。
Because this one, I think maybe 5 years ago you might remember this one. Now you probably not able to remember. So I also don't remember about this one.
啊，
明天就是明天。
他的手风，他的名啊。
So this case actually, yeah, I won't stay too long here. You can see that actually it's still the same thing. So ultimately this is still a closed system. So it is still Q minus W equals to delta U. And so this time, what you have here is actually work in. So you will be left with basically the work shaft or the work in equals to MCV T2 minus T1. So the difference here is that from the start, these are all mixture compared to the previous question. The previous question, they exist individually first, so you can actually find their own respective change. But in this case, they are mixture from the start. So which means when you look for this, so with this here, right? T2 you need to find, like the question asked. T1 is given, but this T1 is based on the entire mixture. So meaning these two you have to find their CV. You need to find their mass, their respective mass and their respective CV. So of course, now the main issue here is that you don't act to use actually. No, okay, don't have. So you need to. So first off, you need to find out what is the mass, the total mass. There's one more information here. So total mass. Once again, you can use the initial volume, the initial pressure, RT1, in order to find the mass. But of course, okay, maybe we look at the CV first. CV is easier to find. So CV is just the total of mass fraction of the individual multiplied by the CV. So you get the CV from the table. You use each of them multiplied by the mass fraction. You can get the final CV. Okay, so CV is an easy one. CV of the mixture. This is an easy one. Now, mass. So, okay, so we need to find these two things, like I mentioned just now. So we need to find CV, so now we need to find mass. So we need to find mass, but unfortunately we don't have R. Once again, because we don't have R of the mixture. You cannot use RU in this case also, because RU will only give you mole, which is not very helpful here. So what do we do? So here we need to find R. So R, we know that it's just RU over M. But then MM is actually mass over this, right? So do you see a cycle here? Or rather a loop here? You need this to find this, but you need this to find, but then you need this to find back this. Actually, it's okay, right? So, because, right, molar mass is a ratio. Like, it's the ratio of the, wait, did I get this the body? I get it. Molar mass is, oh, correct, right? Mass over mole, right? So, it is just simply a ratio. So, what you can do here is just like what we did in the previous question. You assume a mass first. So meaning, let's say, yeah, you assume 1 kg first. So this is not the actual mass. So if you assume this, then you can get their individual mole. Right? So you assume 1 kg of mixture, so then N2 will become 0.15, He will become 0.05, this will become 0.6, this will become 0.2. So once you get that, then you can find their individual mole. So this is the number, the total number of mole based on 1 kg of the mixture. So when you use the 1 kg divided back by the total number of mole, you should get the molar mass of the mixture. Then after that, you use like this to find R, then you find the actual mass. They won't be the same answer one. Because that you are just assuming for you to get the constant value. Because number of mole and number of mass, they're dependent. Right? You have this amount of mass, then you have this amount of mole. So that's why, so based on 1 kg, we found this number of mole. Then once you divide back, you can get the molar mass value. Because this is just a fixed value. It doesn't matter. Because this increase, this will increase. So then you based on this, you find this value. Then once you get the R, sub back in, you get the actual mass.
So cannot we direct just use the mass equals to H and to find the
To find the M.
mass.
But you don't have total mass.
Just assume 1 kg cannot directly.
If you assume 1 kg, then what's your total mole? Yeah, that's what we do. You assume 1 kg, then you find total mole. Then you find MM. It is exactly what you said. It's just that just now you can assume either 1 mole or you assume 1 kg. You cannot assume both, right? Because they are dependent one. So here in this case, I assume 1 kg first. Then based on the 1 kg, you know what is the mass of N2He, CH4, and C2H6. Then from there, you find their number of mole. So then that is the amount of mole when you have 1 kg. So 1 divided by the number gives you the molar mass.
kilomole, then we can direct get the more less more.
If you assume 1 kilomole, how do you get the mass? Because you have mole fraction, you have mass fraction, you don't have mole fraction. Usually we depend on what kind of fraction that we have. If you have mole fraction, you assume 1 kilomole. If you have mass fraction, then you
除
assume
以
1
它的这个
kilogram.
value with 一个
Because you want
那
to
我们
make
就
use of the
把
fraction.
m 的 m
Because these values are not the actual mass of
Ah,
mole. They are just a fraction.
对，这你
So
哎
when
喂
we
这个
assume, we
mm
assume
加
use
起
of
来
whatever that is given
三
to
个
us.
的
这两个都是
四个
这两个是都对。
哦
我要找摩哈，那这个是摩，对，这四个
哦
摩加起来
这个四个模的哦 OK 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 这个是我的 number of 模啦 OK
Okay, I will stop here. So tomorrow I will enter new chapter. So by saying